I was a decision maker in bringing the water jet in. The water jet, I was convinced, would change the way people looked at us as fabricators. You know, it was a tough decision to make because they are very expensive and they're expensive to maintain and run. But I just knew that it was one of the tools that really converts your company into being a real player in the sanitary design industry. And the reason why is because of its accuracy and its ability to cut stainless steel accurately. And stainless steel, as we know and have discussed before, is the material used to fabricate sanitary design. Well, with the water jet, when we decided to buy that water jet, within that first year that we owned it, so the first year that we owned the water jet, we were running 2 shifts to keep up with all the things that were getting sent our way to cut, and it just reassured us that we made the right decision to buy a water jet. How busy we kept it at first. Now, Steve, you might have some insight on as well on how a water jet will change how people use you and look at your company being capable of doing that kind of work.
Changes everything,
Yeah.
basically. It just gives you so many more ways you can design equipment and things you can do. You know, in the past, it was kind of difficult to cut stainless steel especially, but cut intricate shapes was really not anything you would do. But the sky's the limit with a water jet. You can, if you can imagine it, you can almost do it. You know, about anything you can think of, you can make a shape-wise on a water jet.
We worked for Steve at the time that we bought the water jet, but yes, you have to outsource that. When you outsource the water jet cutting, you're not their #1 priority. Okay, so they'll tell you, well, we're a week out, we're 2 weeks out, and so consequently you can't get the parts when you want them. Yeah, there's times where we really have to juggle things and maybe stay late and get the part cut so we have it for the next day or even that day. You know, there's been times and where when it's our guys and our water jet, you know, we can twist some arms.
We can do that. We can make that happen.
Yeah, we can get it done. If it's someone down the road that we're using their water jet, you know, they don't care about us like we care about ourselves and our customers. All in-house, we can work together a whole lot easier to get parts made quickly. You know, and sometimes that doesn't matter, but for a lot of these food plants, as we all know, they expect the impossible. And the reason why is because, you know, time is money. And when they're shut down, they're losing a lot of money. Food plants cannot afford to not run and not fulfill orders. I actually have a story to tell about Steve and I. You know, we work well together and always have, I think. And and I remember, now this has probably been 10 or 12 years ago. And Steve drew these spatulas. Do you remember those spatulas with the weight on them?
Yes.
And these had direct contact with a food that doesn't get recooked. Okay, so it's a final step. It's ready to eat.
Ready to eat. Yeah.
And Steve, because, you know, he's such a nice guy, at the time all I had was a plasma. And he says, well, let's go ahead and cut them with the plasma. You know, because he wanted to work with us and, you know, we wanted to do the job. So we did. And the edge on the cut eventually started rusting. Or, you know, it was hard because there's a slot in there that you couldn't really get to clean up the edge. With a plasma, you have to get rid of that slag coating, right? I guess right on the edge of the stainless. And in the environment it was going into, it just didn't work out well. you know, and so I'm sure Steve at the time was like, man, we shouldn't have done that. You know, we should have got someone to water jet it. And of course they used them. We figured out a way to make it work. It just wasn't ideal. If we would have cut those on a water jet, there wouldn't have been any work to do except take the burrs off.
It would have been perfect.
It would have been perfect. And
Yeah.
and so when we got the water jet, now we're capable of really doing anything that a designer like Steve can throw at you. Okay? There's no limitations, right? You can just, I mean, there are a few.
There are,
But for the most part, we can tackle any job,
right.
you know, that comes our way. And so that's just a thing, something that I can think of just off the top of my head of things that's happened in the past where we could have contracted that out, got it. It would have taken forever, would have taken twice as long. We used the plasma, it just wasn't the right tool to use.
Usually it doesn't have to do with sanitary design. We use the plasma for heavier work and carbon steel.
Sometimes we'll use it for building decks, even though the deck is sanitary design. We can use it for that.
I mean, we can use it for
But it's a bigger
stainless,
scale.
but- yeah. And the cut isn't as nice as a water jet. Before I worked here, I had a business with another guy. And this is basically what we did on a smaller scale. And we didn't have anything like that. We didn't have a plasma or a water jet. So we had a saw and we had tubing and that's how we built things. Then there was a guy had a little water jet in his garage that we got to use in some. But like Chad said, we were at his mercy in terms of when he could get parts done, and also the size. It was pretty small, so we were really limited. But immediately we saw the potential of what a water jet could do for you. So we got one, and it changed everything. The first thing I designed with a water jet in mind was, of course, it didn't have any tubing. It was all flat material that had slots and tabs. And I remember we brought the material, it was just these flat cut pieces, into the shop. And the guy, the welder that was going to put them together was like, how can I do this? And I said, well, let me just show you. Stood the pieces up and the tabs fit in the slots, and he did a little welding, and all at once here's this nice looking frame that was really easy to assemble, very sanitary. There was no tubing, no enclosed area at all. And it was like a light bulb turned on. It's like, this is the way to do it. And we kind of haven't looked back since.
I guess sometimes with a plasma, when it cuts the edge of the metal, okay, say it's a 1/4 inch, it's not a square cut with the plasma.
It's tapered a
It's
little
tapered
bit.
or it's rounded. With the water jet, I mean, it's a knife edge. It's a square cut. It's like it's better than a shear edge. You know, it's just a square cut. And so when you can do that, when you make those tabs, it can slide in, you know, it's just so much more accurate. There's no need to use a grinder. I mean, you just think about like a farmer, okay? He's out there in his shop, he's got a broken whatever on his implement. He goes over and he cuts off a chunk of flat bar with his oxyacetylene torch. He's got to clean that edge off. It's not smooth. He's got to clean it off, maybe even square it up, depending on how steady of a hand he is, and clean that up with the
And
water.
now and that edge is not going to be straight or
crooked
square
or
anymore.
Yeah, and so with us, you can slide it through the tab. Once it comes through, it's square on the other side. It's flush. Or whatever. You know, it's just so much more accurate where when it comes off the water jet, you won't have to do a lot more to it to weld it together. I mean, we have to take burrs. Sometimes we're building guards, you know, with wash-through slots or whatever, and we have to clean that burr off so no one can get cut. That's how accurate it is. It's so sharp. It's, you know, the edges need smoothed off so that no one cuts themselves. It's a knife edge sometimes. That's how accurate it is.
A water jet is accurate, but you kind of have to know the limitations too. It's not like accuracy that you could get from a machining process, for instance. It's accurate to within 10,000ths of an inch or so, which is 3 or 4 sheets of paper thickness, which doesn't seem like much, but you know, for some things that's a lot. That's really not very accurate for some things.
One thing we can do is we can cut holes that you can run a tap right into it. So it's accurate enough to
We can do that.
cut the
yes.
hole, and you don't have to pre-drill it to run a tap through. We have a lot of people sometimes that ask, well, why don't you have a laser? You know, and you've dealt with parts that have been cut by a laser, and a lot of people do use a laser for sanitary design. And I don't know about the brand new ones, you know, maybe they've figured it out, but it just isn't the same edge and same cut as a water jet to me. It's just a little rougher, a little more crude, and it works for some things.
Yeah, the technology's
It's always-
changing all the time.
It's always
but
improving.
I think you could, maybe this is still true, that you could cut thicker material with a water jet over a laser. I think in terms of accuracy, it's about the same. It doesn't generate heat.
Not at all, yeah.
And another thing is a laser can really only cut steel. We cut a lot of plastic.
Yeah,
on
that's
our
true.
water jet, and we cut rubber.
Yeah.
And I don't know if we've cut glass here, but you can. I've been involved in cutting glass with a water jet.
We could kind of touch on that too, because we cut a lot of our wear strips out of
We really
with the
cut
water
a lot
jet.
of plastic with
Yeah.
our water jet, and it's again, it's a game changer with plastic, also.
Yeah,
And you can't do that with a laser. A laser won't cut plastic.
one thing that just kind of quickly, you know, talking about how we can cut, the water jet cuts both steel and rubber or plastic or UHMW.
Or wood,
Or
or-
wood. Say you need a flange, you know, for a pipe or whatever, or even a square flange for a piece of duct, and you need it to have a gasket. You can use the same cut file as the flange and cut exactly the same gasket that goes in there. So you can cut the gasket out of rubber and the flange, and it is dead on. It's nice.
And both things came off the same machine.
And that's changed the way that we design, really. And
It is.
because everything has to be drawn on a computer. Everything. I just real quick, I had a guy the other day, not gonna call out any names, but they made this nice drawing on a piece of paper of what they wanted, and they're like, wow, here, so this will be cheaper because you won't have to draw it now. And we just chuckled. No, it doesn't work that way. Yeah, this helps, but we still have to convert that into a DWG or DXF file, because the water jet follows those coordinates. Yeah, it's just got to be electronic. I love too. Some people say the shop cut this hole in the wrong spot. You know, like I drew it, and they changed the location of the hole. You know, nope.
No, the
that
shop-
was me. Okay, the hole's in the wrong spot because I drew it wrong.
I did it wrong.
That's right, it was me.
Yeah.
They didn't, you know, the machine didn't mess up and just move the hole. That never happens. It follows those lines exactly, and if the hole's in the wrong spot, that's because it got drawn the wrong way. And if it doesn't fit, and this has happened more often than we'd like, we can usually go and find the mistake really easily because it's in the drawing.
It's probably worth mentioning the 3D design capabilities that It all is so interrelated anymore. We do almost everything. I'd say 99% of what we do is really 3D modeled. And so if there's a hole in the wrong spot, it's not so much, well, it is because someone might have made a mistake, but you can see it in the model. I hate that when we find a problem and then I go back to the model and I can see in the model, yeah,
it was wrong.
that's
We
right.
just missed it. You can definitely see, you're like, oh, how come I didn't see that? Because you could see it in the 3D model. What's in the 3D model is what gets made.
It's literally what gets made.
It is. And that's what gets
and
cut.
it's kind of a neat process, I think, from concept in your mind to a 3D model. And there's, it depends on the job, of course, but a lot of times there's a lot of iterations between what you think and what really ends up being. But the beauty of it is you can see it, and you can rotate it, and you can see how pieces fit together. You can see interferences if you look. And then from there, it's really easy, quite easy and quick to get that 3D model into an electronic file form that then can be turned into a path for the water jet to follow. In my mind, there's two ways to view a drawing now. There's a drawing that a human needs, and that's what you refer to, the blueprint. That has dimensions, that has notes, that
A shop drawing.
shows the thing, whatever it may be, how to build it. Well, the water jet doesn't care about that. It needs to see the outline of the part. So it doesn't need dimensions, it doesn't need any text or anything other than the path of the part.
We created departments, in each department in the shop is intricate in this whole process, because the water jet guys, they cut it and it moves on to the next guys, and the next guys are the foreman crew. And without them, this wouldn't happen. And so
Really, so the press brake and the forming department, in my mind, is as important as the water jet itself. They do get a blueprint that would show the part and the way that part looks after it's bent. And they'll have text that might give them a dimension, give them an angle of bend, everything that a person would need to make a part.
And two, you can really, when it moves from the water jet to the forming department, you can really mess it up by bending it the wrong way. And so that's why they're so careful, because you have to see it in 3D, understand that this goes this way, not this way, and kind of transitioning into the press brake. One of a year and a half ago, actually last year, we were able to purchase a new press brake. And so we bought, with it, we bought the Willa tooling. And for those who don't understand, the tooling is, the dies that actually, you've got a receiver die and a upper die that, bends the metal. And even into our 3D software, we try to calculate the K factor, I guess. So
the way it bends.
The way it bends, and that translates out to the press brake, and we're pretty accurate on that.
I'm always impressed with how accurate the bends are. I could model it on my computer and it's perfect. But when they actually bend the metal on that press brake, which is such a nice press brake, it turns out really, really accurate.
And yeah, that's exactly right. Knowledge, understanding and utilizing the knowledge that you gain by, fabrication. There's a lot of years of experience that go into knowing what you're doing, and there's a lot that goes into that behind the scenes that no one ever sees. but having the right equipment, the right skill set is everything.
It's everything.
Yeah.